So today we'll be trying question number 1 of ISC 2014. The question is on composite magic number, basically numbers which are composite as well as numbers which are magic. Now composite means something which is not prime, right? Magic number, now they have given a recursive definition. If you notice, a magic number is a number in which the eventual sum of digit is equal to 1. For example, 28 is equal to 2 plus 8 is equal to 10 is equal to 1 plus 0, and you get a finally a 1. Now if you notice, prime number we have discussed many times earlier also, when we're writing the program we'll see it again, but magic number, they have represented the program as such that you might believe that you should do it recursively or you should take a loop for the magic number part. But if you notice, eventually when you are adding the sum, it will come to 2 digits and then it will come to 1 digits. Any doubt in that?
No, sir.
So highest 2-digit number can be 99, and then when you add 9 plus 9, it becomes 18, then 8 plus 1, 9, and you finally get 9, right?
Yes.
Now if a number is finally adding up to 1, what does this tells you?
It is like a multiple of 10.
Yes, so which means
it.
that if we do modulus 9 and we get 1, our job is done. Pay attention. So basically, if you want to check whether a number n is a magic number or not, there's no need for taking any loop and all. You just say if n modulus 9 is equal to 1, done, right? So that will make the program fairly efficient. Also notice that we are talking about the prime number part, so we'll write an efficient logic for the prime number. Not prime number will give you a composite number. And please also notice that as per our current logic, in which order we check also dictates the efficiency. For example, checking whether a number is magic number or not is not an expensive operation if we consider the modulus logic. But checking for a composite number will require some work. So when we are doing it, we'll first check the magic part and then we'll check the composite part so that the program remains efficient. What's the point of making more effort and finding out whether a number is composite or not, and then it's not a magic number, right? Okay, so let's begin. So we'll write a fully object-oriented program like we normally do. So I have a template already made. We'll just have a look at what they are asking. So they are asking for this format: m is equal to n is equal to. Okay, so let's begin. So we need to enter two numbers. System dot, we'll first display the prompt, system dot out dot print, and we'll say input. That will be followed by a tab character, and then we'll say that okay, int, sorry, we have to say m is equal to as well. So we'll say m is equal to, and then we'll say that okay, int m is equal to in dot next int. So that takes care of the first part. Then in the second line they are saying n is equal to, and there is a tab character before it, so we'll make provision for that as well. So I'll again copy this line, we'll paste it over here, and we'll say that okay, this is nothing, so directly /t, and instead of m we'll say n is equal to, and then we'll take the input again and I'll say n. So now we have our inputs. Now they have given a constraint that only if m is less than or equal to n, then we are supposed to proceed, right? And they are displaying the message invalid input otherwise. So what we'll do is, let's check that as well. So first we'll say that okay, we want to display output because that word is to be printed. So we'll make this input into output. Obviously this has to go away. And once this is done, we'll check. We'll say that if m is less than or equal to n, less than or equal to or just less than, what was the language used? Where is it? Where m is less than, not equal to. So if m is less than n, then we'll continue normally, else we'll display the message. I still believe that system.out.println is there in the clipboard, so I'll paste it. And then in this case we'll say invalid input. So this is done. Otherwise, we come over here. Now we want to make a proper object-oriented program. So now we need a class.
Class.
So we'll say that class, what to call the class? Number or composite magic number? What to call it? Okay, let's say composite magic number. Composite magic number. And then we'll have our instance variable. We'll have two instance variable m comma n. That's the range. And then we'll initialize the value using a constructor. So we'll call it magic composite.
So it is reverse. It is composite magic.
Oh, sorry. Let's copy paste and then it will be faster. So composite magic number, and we'll take the two variables. So int n comma int n, and then we'll store it in the instance variable. Since the name of the variables are same, so we have to use this. So we'll say that this dot m is equal to m and this dot n is equal to n. So initialization is done. Okay, one more thing. Instead of checking it like this, I'm not going to do it, I'm just telling you. What you can do is that you may consider having it in a try catch block, and then you can throw the illegal argument exception also and then display this message also. That would also look neat. But anyway, since we have already done it, it doesn't matter. So composite magic number object is initialized. So let's initialize it over here. We'll create an object now. We go over here and we say that okay, obj is equal to new composite magic number, and we'll pass the value of m and n. Okay, now how to proceed? If we back to the question, they are displaying the composite integer numbers in that range, right?
Yes, sir.
And they're also giving the frequency. Now we are left with two options, that once we are printing it, we can store the frequency, and later on when someone says to print it, we can print it. Which option will you prefer? A separate function for having the frequency of composite magic integers, or just done inside the output only? Come on, let's debate over this. What should be done? Which is
if we want to do it in the real world, then we should do it separately, because there might be cases when the user just wants the frequency or just the magic numbers. So okay. But in this program, we are seeing that we have to print both of the things, then we can do it in a single function as well.
So okay, we'll take the middle approach. We can have a variable for the count. We'll populate that variable, or let's have a process function and then display it separately. That's what you're trying to say?
Yes, sir. For this program, yes, that's what I was thinking.
Okay, so we'll go to the next line and we'll say obj dot process, and within the process we'll do the main job, right? And then we'll say that okay, we want to print it, system dot out dot println, and we'll print the object. So when you are printing the object, we'll do the first part and then we'll display the message. Message means, sorry, the count, this part. Okay?
Yes.
So we go down, we say that okay, system dot out dot println, we display our message, and then we'll say that okay, obj dot get frequency. So get frequency clearly indicates that we are just getting it, we are not calculating it. Clear?
Yes.
Okay, so we go over here, let's declare our functions. We need one function by the name of process. Then we need one more function by the name of get frequency. So public int get frequency, and there we'll just say return frequency, which indicates that we need a variable by that name, frequency, and that has to be initialized as well. So frequency is equal to 0. Any doubts till this point? Am I missing something? Probably not.
No, sir, it's fine.
Okay, so let's come to the process part. So in the process part, what we have to do, we'll store our output. Let's have one more variable over here. Output is equal to nothing. No, only the declaration part should be there. And here we'll say that, okay, output is equal to nothing. Or it shouldn't be here also. When we are doing it, then we'll do it. Otherwise, it will be added twice. So we come over here. So in the process, what needs to be done? We need to find out whether a number is composite or not. And for checking the composite, we are supposed to know whether it is a prime or not. So let's make a function for prime. I'll say private int, not int, private static boolean is prime. We want to check whether a given number is prime or not. Let's say the number is n. Boolean spelling is wrong. I'll correct that first. Boolean, right? Okay. So let's begin. If the number is less than 2, it cannot be a prime number. So we'll directly say return false. If the number is equal to 2, 2 is the only even prime number. So we'll check it separately. So if n is equal to 2, we will say return true. And then we'll go to the else part, and then here we'll say that if number is still even, n modulus 2 is equal to 0, it can't be a prime, so we'll say return false. Any doubt till this point?
No, sir.
No. If we are reaching this last else block, what it indicates? The number is odd. Right? That's the meaning if you're reaching till this line.
Yes.
Now here what we'll do is, and odd numbers may or may not be prime. So we need a limit. So we'll say that, okay, limit is equal to int math.sqrt, and we'll say n. Because beyond that, if you go till half, it gets improved, but it doesn't improve to that extent. Please understand, whenever you are trying to find the factor of two numbers, it comes in pairs, and the repetition starts after the square root. So if you've already checked for, let's say you are checking for 100, and 100 so won't be taken in this case, but let's say if it was 100, then if you have checked for 5 into 20, we should not check for 20 into 5 later. So that's why we are doing it now. So we have already checked for numbers till 2. So now what I'll do, I'll take a variable for the divisor. We'll start from 3 and we'll take the divisor till it is less than or equal to our limit, that is the square root. And every time we add it by divisor plus is equal to 2. Because there is no point in wasting time by dividing it by a even number. And now please understand, we are not starting from the number 1. We are not going till the number. If there is any factor, that means that factor is at least the third one. So we'll say that if n modulus divisor is equal to 0, we'll say return false. And if this loop completes and you come out, it's a prime number. So we'll say return true. Any doubts?
No, sir.
No. So prime is done. And now we need the composite one. So we'll say public static boolean is composite, again n, and this is just the inverse of prime. So we'll say return not is prime n. Done?
Yes.
Okay, now we come to the process function, and in process function we'll have to take a loop. So let's do it. So we'll say that, okay, int I is equal to, we have to start from m and we have to go till n, and then we'll say I plus plus, and then we'll check for all the numbers. And before we check, frequency is already 0 over here, but please understand, someone might call the process function twice, so it's better that we initialize it over here. So now here,
Sir, I was thinking that we should calculate the frequency separately. Like I'm not feeling satisfied with doing it in the process function.
so you'll run the whole loop again.
No, sir. My logic was that suppose there may be a case when we just want the frequency, not the numbers.
Okay, so we can do it. So in that way, we can also call the is process the process function from the get frequency also if you want.
Yes, sir. That's what I was saying.
And that's also
That
that's also a nice idea. But I mean, if you are not processing and you're trying to get it, the question is silent on this. Okay, let's do it. No problem. Okay. But then
yes.
under normal course, it will be called twice unnecessarily. Now we have to make a decision. Or you
Okay, so
can,
let's continue
or
with
there is
this.
one more way out. We can call the process function from the composite magic number function. I mean the constructor itself. That is also one of the possibilities. But then what's the process doing over there? Okay, let's say user call. I mean that much user have to be careful. What do you say? If the question is
Okay,
framed
sir.
like this, even that is the
Okay,
issue, na?
sir.
We have to find a balance between efficiency and object-oriented programming principles in this case.
Okay, sir.
Okay,
We'll
so we are over
continue.
here. So now what I was saying that we can check for prime first and composite later, or composite first, prime later. But what we'll do is we'll check for the magic number thing first. So we'll say that, okay, we haven't defined magic. Hold on.
Is magic, yes, sir.
We have to define is magic also, which is actually just a one-liner using a new logic. So we'll say public, static, no, not public, private. In fact, the other one should also be private. Why it should be available outside? Private. Come over here and we say private static boolean, and we'll call it is magic number int n, and we'll simply say return n modulus 2 equal to n modulus 9 equal to 1. Done. So we come over here and now we say that if is magic number I and is composite I. Okay, I'm not liking the name. If it is magic number, then it should be composite number. What do you say? The language. Number,
Yes, sir.
number, composite number. Now it looks nice. And this also becomes prime number. Okay, so if it's and done. So if both of these are satisfied, we'll just say that frequency plus plus. Done?
Yes.
Okay, so once it is processed, the frequency is calculated. Now we need to print it as well. So what we'll do is we'll say public string to string. We can create a display function also, but this looks neat. Oh, wait a minute. We can form the output over here only. Here we'll just return the variable output. We forgot to populate it.
Yes.
So we'll say return output, and here when we are processing it, what was it looking like? So the composite integers are, we are first displaying this message. So let's first store this message inside this. So we'll say that, okay, output is equal to this. And then let's have a /n and /t so that it aligns properly. I believe that I forgot to give a tab over here, but in the real question paper, there was a tab over here. There was a tab. They always give formatting like this, right? Okay.
Okay, sir.
So this is done. We come back over here. So the composite integers are, is output an integer? Sorry, this shouldn't be an integer. This should have been a string. So we come down. So this is it. And then we have to add all of them by a comma, and there is no comma at the end, isn't it? Now you don't know in advance how many will be there. So what's the solution? Yes, how to
So we
resolve
can
this
find
now?
the substring. So at the end, we can find the substring.
Exactly, that's the only way which we are, only thing which we have. So we'll move this frequency thing inside, and we'll say that, okay, output plus is equal to, we'll add a comma and a space, and then we'll say semicolon. And when we are outside this loop, we have to get rid of last two characters, isn't it?
Yes. So
So
it should be outside the loop.
Oh, sorry, at the wrong place. Hold on. So once the loop is over, we'll come out and we'll say that output is equal to output dot substring. We'll take everything from 0 and then we'll say output dot length minus
2.
2. Exactly. So this will get rid of the last two characters. So is the program complete now? Are we forgetting anything else? I don't think so, right?
So we have done, yes.
Okay, let's run it and see what is happening. Let's first see the first test case. M is 10, N is 100, and the frequency is supposed to be 8. 10 and 100. So I'll run the program and I'll enter 10 and then I'll enter 100. I'll press enter. So this example is working. Let's go on to the next one. This is 1200 and 1300. So we'll again run the program and then we'll give 1200 and 1300. We press enter. This time the frequency is 9, which is correct. And then invalid input will obviously work, but just for the sake of completeness, 120 and 99. So we'll say 120 and we'll say 99. We'll press enter. Invalid input. We forgot to give a /n at the end. So it's good that we checked it. So where is it? Here. We'll just say print ln. Yes, any doubts?
No, sir.
Okay then. That's all for today. Thank you.